Hi, in this video we are going to learn about cycle detection. Cycle detection may prove to be very important because, as we have learned before, we can use topological sort only on DAGs, so directed acyclic graphs. And if there's a cycle, it's no longer a DAG, so we can't run topological ordering. Or for example, when we are constructing an operating system, it's very important to schedule the jobs. For example, there may be situations when deadlock appear. Deadlock is a situation where task 1 is waiting for task 2, task 2 is waiting for task 3, and task 3 is waiting for task 1. It's a typical situation of a cycle, so it may be important to be able to detect these cycles, and it can be done in linear time with the help of depth first search. So let's get started. I'm going to create a package. I'm going to create our class, but we are going to modify it a bit because, to be 100% precise, private is going to have a name. We want to detect whether it has been visited or not, but there's a stage when it is being visited, and we want to detect it unless we couldn't find the cycles. Yes, and there's a list containing the adjacencies. Okay, we are going to override the toString as usual. This is that name. We are going to create a method to be able to add a neighbor. Adjacency list add vertex, and we are going to override and generate getters and setters for the being visited, for the visited, and this. And in the cycle detection, I'm going to implement the depth first search in a different manner, because depth first search is able to traverse separated graphs. We have to give it, for example, it's going to get a list of vertices, a vertex list, and we're going to iterate through this list. And if vertex, is visited, if we haven't visited it yet, then we're going to run the depth first search. We don't set vertex to be visited because we do it in another method, public void DFS. It's not that important. In this method, we just make sure that if we have separated graphs, for example, like the web, there may be different graphs. It's not sure that the websites of Washington is connected to the websites of Uganda, for example. They may be different clusters which we want to traverse all. DFS. And here we set vertex that set visited false, because here it is not visited. We just start to visit, but it's not visited. And vertex that set being visited true, because we are visiting it. And vertex v vertex that get adjacencies, and we say that if v that is is visited, if it's not visited, we set it to visited, and we call this method recursively. And at the end here we say that the vertex set being visited is false, because it's over now. So visited true, it's visited. Usually we don't have to detect whether it's being visited or not. We know that it's going to be visited because we run this method. And we check here that if v that is being visited, so I think in graph theory it's called a backward edge, that we going to visit a vertex that's being visited. So it's a typical case of a backward edge. We just print out that cycle is detected. Okay, what's the problem? We have to import it. Okay, so far so good. I think we can test it. I'm going to create 3 vertices just for demonstration purposes. Two, vertex 0, add neighbor, yeah, vertex 1 and vertex 1, add neighbor vertex 2. There's no cycles in here. Cycle detection, run DFS, what's the name? Detect cycles, okay. And for example, the starting vertex will be the vertex 0. Yeah, we have to create a list of vertices. Array list. And vertex list dot add vertex 0. Vertex 1, vertex 2, maybe I copy it here. Okay, detect cycles, and we give the vertex list. Okay. So nothing happens because there's no there isn't any cycles. But if we set 1 and 2, yes, we create a cycle here. It's going to be a backward edge. The 2 is pointing back to the 0. Cycle detected. Yeah. It's very, very good. We should, it may be, I think, we should return. We should definitely return. Cycle is detected. So that's about cycle detection. In the next video, I'm going to talk about shortest path. Thanks for watching.